Hi everyone, my name is Trang and today I'm here to present my plan to teach about the Boyle. I will start with some general information about the context. I assume that the students are not familiar with the equipment, so I'm going to show the lab apparatus for them. And they know about the inquiry-based learning in many previous experiments. And I will turn to girls' lesson. In this part, there are two important things we need to get. The first is knowledge. We need to make students understand about the Boyle law. It's considered the condition and the formula of this law. And the second thing is the inquiry skill about the design experiment, predicts the result, and manipulate experiment and true representation. And I think the most important part is I will talking about the teaching and learning. The first is the eliciting problem, and I will show them the short video about a person who is breathing at the bottom of the water pool, and the student can see that the air bubble increase the size when getting closer water surface. And my purpose is make them realize the relationship between pressure and volume in an unchanged amount of gas and at a constant temperature, and I will require them predict that this relationship and ask them what relationship between pressure and volume in an unchanged amount of gas and at a constant temperature. And the secondly is problem solving, because the student can realize the relationship between pressure and volume in some situation in reality, so they need to do experiment to investigate that relation. And I will ask students about the thermodynamic parameter they have learned in previous lesson, and ask them which parameters are keep constant and which parameter change, and how can you measure P and V of an unchanged amount of gas and a constant temperature. After that, I will show the lab apparatus. It's about 2 cylinders and one is connected to pressure gauge, and here is a hand pump with 2 screws. It makes gas come in and come out. And after that, I will require students sketch the experiment. And before they do experiment, I will ask them about are there any disadvantage about this design, and why do you think so? And after that, I will do experiment one time. Can you see in this row the water level is the same? Are the same? And I connect the cylinder to the hand pump. I do it one time. And you can see the water level change is about the P. And is the number of the pressure gauge is 1. And do the experiment many times. We have the data, and I will assign them, record the data, and generate the law by themselves. And the last one, I will conclusion about this law is at a fixed temperature in a volume of gas. Volume of gas is inversely proportional to the pressure exerted by gas. Yeah.
Collect electric data.
Yeah.
And which quantity do you raise?
This is centimeters.
Yeah.
Because the ruler is personal. Because the ruler is personal with the V, so I will take the height of water and it's because it's a ruler have in scale with the volume.
Really?
Yeah. This is the
Okay, so what are you reading? Volume?
No, it's a high. It's a high of water level. Yeah.
High. Then what should you write?
And do it many times we.
One more. You do one more.
Yeah.
So the reading over there is 15.1.
Yeah.
If I see it well, the first height.
Yeah. Is a 15.1, is a 16, is 17.
Hey, how
Yeah.
can you read point 1?
I'm just in a proportional because it's why here is then more 15 a little bit, so
No, it's not a good way. You have to read based on the skills you have. You cannot make any guess. Some
no,
level is there
it's-
get closer to the 15,
yeah,
so you have to read 15 anyway.
but it's higher 15 a little bit,
But is it close to 16 or close to 15?
close to 15,
Do you know about system
close to 15,
error?
yeah,
System error. Yeah.
Yeah.
One scale has minimum value that we cannot reach smaller than minimum value of this rule. So you cannot write down as it.
And also the issues with the reading pressures. What is the smallest scales in the Gauss pressure?
pressure is
Pressure ball.
smallest scale,
Yeah.
the
What
smallest
is the
is
minimum pressures? Minimum change
is a
0.05.
0.05,
Yes, 0.05.
Five.
And the
Yeah.
rate 0.9, 0.16, 0.29.
21,
21 is wrong measurement. It can be 20 or 25, 15, and the first one is 0.09.
per 1,
It must be
Per one.
1.1 should be 1.1 only.
ah,
So all that is wrong reading. But okay, we have no time. So let's just ask what is the boundary condition for the Boyle law?
so battery condition.
Boundary conditions.
About the gas is ideal gas, and the pressure is smaller than 5.
5 atmosphere
Yeah,
and
I think it's temperature as a constant,
still one more.
unchanged gas,
Sorry?
unchanged amount of gas.
Unchanged amount of gas.
Ideal gas.
And in this case, you will do the measurement up to the pressures of 1.2. So if your friend suggests you, hey, I want to do, because the scale of Muslims value the pressure they can measure is 2.5, should we do up to that pressure as well?
Sorry, I don't understand that.
Don't get it?
Yeah.
Now, that pressure ball can measure the pressure up to 2.5.
Yeah.
Okay?
Yeah.
And the data set is just about 1 point. So one person says should we continue to reduce the volumes of gas and then we
Increase
can,
the
up to
pressure.
2.5 because the device can still measure the pressure. So how should you react to it?
Because just a gas of the cylinder is unchanged, so you can see the high the cylinder just 30. So you want to make a pressure in 2.5, it can be not can be.
It's not possible, you mean? I think it's possible, but should not do that. Okay, the second thing is you see if you take it randomly and the water surface is not exactly fit with a certain scale on the ruler. How can you adjust to the situation where the water surface is exactly in line with the scale on the ruler to minimize the errors in breaking the height? You know how?
I think it's on in order to the way you see the scale, the ruler. It's on in order to it's depend on the way you see the ruler.
Depends on the way you see it.
Yeah.
The correct
Because
way is
it's-
always put your eyesight in the perpendicular to the water, to the scale is okay.
Yeah.
I mean, you just simply turn one round to raise the water level up.
Yeah.
And the water level is not necessary, not always in line with the bar, with the scale and the ruler. What I suggest you is you just turn a half or just turn a little bit, and you can do it right now. You can turn a little bit and you see the gradual change. Now, be careful to see the gradual change in the attitudes of the water. You change gradually. That you see the change in water surface? Yeah. And then when it reaches to the scale, when it is in parallel to the scale, you read the volume and you read the pressure. So you reduce it. And what I don't like is you introduce students to the equipment and then you ask them to sketch, and that is meaningless to me.
Yes, I refuse because I want to, because it's too hard if students don't know anything about the equipment. So
Okay, you can introduce them, and the sketch on the board does not add anything to the procedures to me. Yeah. Okay.
Next.
Let's go ahead.
Now.